The capacitor plate has two metal plates and these plates do not touch each other. With the use of voltmeter, we can determine the amount of volts. Moving the battery upward, the top part will
Step
become
1.
positive and
On
the
the
lower
Modules
part will
tab in
become negative.
Canvas, press the
They
FET
both have
simulator
equal
and wait until it
electrons.
is fully loaded.
Then, adjusting the
Step
battery
2.
downward,
When
the
prompted,
electron
you
will
will have
change.
two options
The
to select,
negative electron will
either
be on top
capacitance
and
or
the
light
positive
bulb. In this
electron will
activity, you
be on
should
the
select
lower
the light
part.
bulb option. Step 3. Upon selecting the light bulb option, you will be prompted with a simulator of a circuit. To determine the exact voltage of the battery, select the voltage meter on the top right to add in the simulator. Then, connect the two plugs to each of the wire connecting to the battery. 4. For table A, we need to set the voltage to 0.45 volts and the distance of the separation must be held constant. The group shall decide the value for the distance of separation. The distance of separation can be adjusted using the green arrow on top of the plates. The values for the area of the plate must be in increasing order. You will input the values of the charge in the plate and the value of capacitance that can be found on the top portion of the simulator on the table after each trial.
In my group, we discussed that in this experiment, me and my group mates are tasked to determine the effects of the voltage of the battery, R of the separation of the plates to the value of the charge and capacitance in the parallel plate capacitor. We have taken that the parallel plate capacitor is comprised of two metal plates divided by an insulator. To regulate the effects of this voltage, the battery area of separation of the plates to the value of the charge capacitance, we use the PHET simulator. It can be attached to the battery so that one plate becomes short of electrons, positive, and the other plates gain electrons, negative. Succeeding charging, an electrical field is formed between plates. Capacitors are placed parallel into issue to issue a higher level of capability to provide a correct value that might not be available.
Parallel plate capacitor is the simplest form of capacitor. It can be constructed using two metal or metallized foil plates at a distance parallel to each other. Between them there was a dielectric. Parallel plate capacitor has two plates and they have both equal dimension.
We analyze the distance of separations of two plates is constant and the plates increases and the distance remain constant. The charge in the plate as well as the capacitance increased.
Good evening, this is lab report conclusion in parallel capacitor lab report. At the center of this experiment was the capacitor and its properties. The function of a capacitor is to obtain, hold, and store charge, especially in the case of short. It was seen in this experiment that a capacitor can be charged up to the point where its voltage is the same as the voltage across the battery. It was found that as the plates of a capacitor are charged up to that point, it becomes more difficult to add more charge onto the plates, which is due to the published repulse forces that occur between the positive charge attempting to be added in the already very positive plate of the capacitor. It was also seen that even after disconnecting the battery from the capacitor, the capacitor maintains its voltage for a period of time, which shows that capacitors do indeed hold, store, and store charge.